Hi everyone, today I'm going to teach you how to draw covalent Lewis structures. So when I say covalent Lewis structures, what I mean are structures that show the way molecules are arranged through covalent bonds. So let's talk about how we make these things. So to talk about how we'll draw these Lewis structures, let's start with the molecule you guys are most familiar with, water. So the first thing we want to do, there's a pretty easy procedural process for drawing these Lewis structures, and it begins with counting up the number of valence electrons in the molecule. So if I looked at my water molecule has 2 hydrogens and an oxygen. Each of those hydrogens have 1 valence electron, and the oxygen has 6 valence electrons. So the total number of electrons in a water molecule would be 1 plus 1 plus 6, which equals 8 electrons. Now, why do we add up the number of electrons? Well, we add up the number of electrons because that's all the electrons that we can share within the molecule. What's a little weird about covalent molecules is that those electrons can be shared anywhere in the molecule. They don't have to stay between the 2 atoms that are initially making that bond, right? And so we're going to see that these electrons have the freedom to sort of go within the molecule when the molecule is being formed. And so we want to add them up so that we can account for them. Now, so first step, add them up. Second step, what you're going to do is you're going to single bond. We're going to single bond all the elements to what we call the central atom. Now, what is the central atom? Well, the central atom will always be carbon if it's present. If it's not carbon, then it's often going to be the atom that needs the most electrons to fill its octet. And the one thing that the central atom will never be, it'll never be hydrogen. So in this particular example, we have hydrogen, hydrogen, and oxygen. We don't have carbon, and we only have hydrogen with an oxygen. So oxygen must be the central atom. So we're going to put oxygen in the middle of the molecule, and we're going to use single bonds to bond a hydrogen to either side. Okay, there we go. Now, what we're going to do is we're going to subtract the electrons we use from the total. So in this bond, that's 2 electrons. And in this bond, that's 2 electrons. So that means that we're using 4 electrons to draw out these bonds. We're using 4 electrons total. So we're going to come up here and subtract 4 from our total. And now we have 4 electrons still to work with. Okay. So what do we do with those 4 electrons? Well, we take those electrons and we're going to add any leftover electrons to the surrounding atoms first, right? Except here's the deal. We're only doing that to fill their valence shell. And if we look at this particular molecule, we see that the surrounding atoms are hydrogen. Hydrogen only needs 2 electrons to fill its shell. And if I look here, that hydrogen has 2 electrons. There's 2 electrons in that sort of yellow circle. And this hydrogen over here has 2 electrons. And the oxygen in the center currently has 4 electrons. So I don't need to add to the surrounding atoms in this particular situation. If the surrounding atoms were anything but hydrogen, I would add to them, right? But I don't need to do that in this situation because hydrogen only requires 2 electrons. So I can skip right past step 3, and I can go down to step 4. And step 4 says if there are any leftover electrons, you're going to add them to the central atom. Now that you've filled the octets of the exterior, the outside atoms, you add them to the central atom. So I do have some leftover electrons, right? I just erase this real quick, get back. I have it. Oxygen, a hydrogen, a hydrogen. There we go. I have 4 leftover electrons. So what I'm going to do is I'm going to add those electrons as pairs called lone pairs to this central atom. Okay. And then I'm going to check. After I do that, what I want to do is after I add them to the central atom, I need to double check to make sure that the central atom has a filled octet. And if I look inside that circle, I see 2 electrons in the bonds, 2 electrons for each lone pair. So that's an 8 total electrons. It's good. I'm done. So this is the Lewis structure for water. And you've probably seen this structure many times in biology. It's an oxygen single bonded to hydrogens with 2 lone pairs. Yep, done. Let's move on to the next one. So NCl3. This one is going to be, so NCl3, let's try this one. We add up the, first step is to add up all of the valence electrons in the molecule. So nitrogen has 5 valence electrons, chlorine has 7. Each of these chlorines have 7 because there are 3 chlorines, right? So 21 plus 5 equals 26 total electrons. So I need 26 electrons in this drawing, okay? Next, I'm going to single bond all the elements in the molecule to the central atom. So which one is going to be central, nitrogen or chlorine, right? Well, there's no carbon. If not carbon, then it's whatever needs the most electrons to fill its octet. Well, if you look at what they need, right? If we're looking at what we need, nitrogen needs 3, and all these need 1. So which one's going to be the center? It's going to be nitrogen, okay? So I put nitrogen in the center, and I'm going to go ahead and use single bonds to bond all of the surrounding elements, which are all chlorine, to the nitrogen. Now, what I have to do is I have to subtract the electrons I use from the total. So I use, for each bond, there's 2 electrons. So I have 2, 2, and 2 electrons in each of those bonds. So I've used 6 electrons. So I'm going to subtract 6 electrons from my total to have 20 electrons remaining. Okay. Next, I'm going to add the electrons to the surrounding atoms first. I'm going to add them to the surrounding atoms first as lone pairs. So if I come along here, I'll copy it this time instead of pulling it down. I'm going to add the electrons as lone pairs to the outside first. So 1, 1, 2, 3, 4, 5, 6. I added 6 to chlorine to fill its octet, right? Because that's what we're doing here. We're going to fill the octet, right? Because we have 2, 2, 2, and then 2 for that chlorine. So that chlorine has an 8 now, so it's happy. So that's 6 that I've used. Then 7, 8, 9, 10, 11, 12. And then 13, 14, 15, 16, 17, 18. I've used 18 electrons. So minus 18 electrons, because I've used 18 electrons to fill the octet of the outside atoms. That means that I have 2 electrons remaining still to go in this molecule, right? It's always important to keep a good accounting of your electrons so you know how much remain. So 2 electrons still remaining in this molecule. So I'm going to come along and I'm going to add those 2 electrons to the central atom. Any leftover electrons, we add to the central atom. If there's any leftover, you always add the leftover to the central atom and then double check to make sure the central atom has a filled octet. Well, if I were to look inside of this circle for the for nitrogen, nitrogen has 8 electrons in there because there are 2 in each of the bonds plus 2 in the lone pairs. That gives me 8 electrons total. So that is the Lewis structure for NCl3. It's nitrogen bonded to 3 chlorines. Each of those chlorines have a filled octet. And there's a lone pair on the nitrogen. Okay, let's try another one. CO2. So I'm going to do the same thing. I'm going to come along. I'm going to do carbon, oxygen, oxygen. Carbon has 4, oxygen has 6, oxygen has 6. That means there's 16 total electrons in this structure. Right? So carbon is there, so that is going to be the central atom. So I'm going to start with a carbon single bonded to each of the oxygens. And I'm going to count for my electrons. I use 4 electrons there. So that means I have 12 electrons remaining. When I add those 12 electrons, I'm going to add those 12 electrons as lone pair electrons to the outside first. So 1, 2, 3, 4, 5, 6. I fill the octet of that oxygen. There's 8 there. And then I go 1, 2, 3, 4, 5, 6. I fill the octet of that oxygen. There's 8 there. But I've used all my electrons. That's 12 electrons I've used. So I have no more left. So unlike the previous ones where I've had leftover, I put them on the center, right? What happens is if there are no central, so there's no leftover, so I need to double check to make sure that I have the central atom has a filled octet, right? And if I look here, it does not. If I look at this CO2, what I can see is that I have 1, 2, 3, 4, 5, 6, 7, 8 electrons around that oxygen. And again, 1, 2, 3, 4, 5, 6, 7, 8 electrons around this oxygen. But if I look around what's around this carbon, it says 1, 2, 3, 4. Okay, so I have 4 electrons. I do not have an octet. So I have to get that number of electrons around the carbon to be an octet. So if I do not have an octet, what I have to do is I have to swing in. Exterior lone pair electrons to make double or triple bonds if the central atom does not have an octet. What does that look like? Well, it looks like this. I come up here and I take these electrons and I literally swing them in. And look at this. By adding those electrons to make it a double bond, what we see is this. I still have 8 electrons around that oxygen. That oxygen did not lose any electrons, but now I have 6 electrons around carbon, okay? And what I'm gonna do is I'm gonna do the same thing again on the other side. I'm gonna have one oxygen share and increase its sharing of electrons, and then the other oxygen increase its sharing. So now if I look here, I'm gonna make these straight lines to represent the bond. There and there. So now if I look here, I have 8 electrons around the oxygen there. I have 8 electrons around the oxygen there, and 8 electrons around the oxygen there. And I am done. That is the Lewis structure for CO2. SF2, same thing. S, F, F. Sulfur has 6. All these fluorines have 7. Fluorines have 7. So that's going to be 14 plus 6 equals 20 electrons. Which one needs the most? Sulfur needs the most. So that's going to be the center. So sulfur, fluorine, fluorine, single bond, each of them. Okay. I've used -4. I have 16 electrons remaining. I put them on the outside. That's using 12 electrons. I have 4 remaining. Those remaining electrons go on the central atom. Bam, done. Because if I look here, 8 electrons, 8 electrons, 8 electrons. That is the finished drawing. Start moving a little quicker. Once you get the hang of it, you can get a little faster. HCN, this one's a little bit of a tricky one. Hydrogen, carbon, nitrogen. It says 1, this says 4, this says 5, right? If carbon's present, it's always the center. So I do carbon, single bonded to a hydrogen and a nitrogen. Now I only have 10 electrons to use in the structure, and I've currently used 4, so -4 electrons. I have 6 electrons remaining. Now I'm going to add them to the outside, but don't forget, hydrogen never gets lone pairs. Central atom's never hydrogen, and hydrogen never gets lone pairs because it only needs 2 electrons. So I'm going to put these 6 electrons all on nitrogen to fill nitrogen's octet. So now nitrogen has a filled octet. So hydrogen has 2 electrons, so it's good. And nitrogen has 8 electrons, so it is good. The problem is this carbon only has 4 electrons, so it is not good. So what do we have to do? We have to swing in electrons. We come along here, we swing in 1 pair. Now at this point, this nitrogen still has 8 electrons, but now this carbon has 6 electrons, and the hydrogen still has 2 electrons, which is what hydrogen wants. So I come in here, I swing in another lone pair, and what I get is what's called a triple bond. I have a triple bond now between the carbon and the nitrogen. And if you look at that, nitrogen still has 8 electrons, but now so does carbon. So that's the structure. Write it a little bit more cleanly. It's HC triple bond N with a lone pair. BCl3. So boron has 3 electrons, and each of these chlorines they all have they all have 7 electrons. Okay. So that means the total number of electrons is going to be 21 plus 3, so that's 24 electrons. Boron needs the most electrons, so that gets to be the center. So we have boron, and we're going to single bond chlorines to the outside. We're going to deduct the amount of electrons we use, which is 6 electrons, because it's 2, 2, 2. So we deduct 6 electrons. So minus 6 electrons. We have 18 remaining. Okay. Now we're going to add to the outside first. So we have 1, 2, 3, 4, 5, 6 to fill that chlorines octet. 1, 2, 3, 4, 5, 6 to fill that chlorines octet. 1, 2, 3, 4, 5, 6 to fill that chlorines octet. Right? We've used 6 times 3 is 18. So we've used 18 electrons. We have no electrons left. We are out of electrons now. But here's the thing. One important thing. Boron only needs 6 electrons. It's one of the 2 exceptions you need to know. Hydrogen needs 2, boron needs 6. So while at first it may seem like boron doesn't have an octet, and many people would be sort of inclined to sort of move a pair of electrons in, nope. We are done. That is the structure for BCl3. Done. Because we have 8 electrons, 8 electrons, 8 electrons, and boron only needs 6 electrons. Okay. And the last one will be this CH2O. So if I look along here, I can see I have carbon, hydrogen, hydrogen, oxygen, right? Carbon has 4 electrons, 1, 1, 6 electrons. So this is a total of 12 electrons. We have a carbon, so that gets to be in the center. Carbon, I'm going to go ahead and bond a hydrogen, oops, a little sloppy. Hydrogen, hydrogen, oxygen, single bonds, all of them. How many electrons I use? I use 6, so minus 6 electrons. I have 6 electrons remaining. I put them on the outside first. Remember, hydrogens never get lone pairs. They're happy, they're done. So I put them on the oxygen first. 1, 2, 3, 4, 5, 6. So now that's 6 electrons. The oxygen is filled, but we are out of electrons, and the central carbon only has 6 electrons. So what do I have to do? I have to increase my sharing by swinging in one of these lone pair electrons in to make a double bond, and I am done. Because if I look now, 8 electrons, 8 electrons, 2 electrons, but that's what hydrogen wants, and 2 electrons, but that's what hydrogen wants, and we are done. Now, this process is not that difficult if you just follow the procedure, right? Follow the procedure, go nice and slowly, take your time. The last thing I want to show you is how to, once you've drawn a Lewis structure, how to input it into Chem 101. So let me stop my share real quick and show you that real quick. Okay, so this asks us to draw the Lewis structure for what's called formaldehyde, which I wouldn't expect you to know its name, but that's the molecule that we just did the Lewis structure for, the H2CO. They have H2CO. You could do CH2O. Doesn't really matter. Same structure that we just drew. So how do we do this? Well, first of all, we need to build the molecule, right? We need to build the molecule. So if we go back to looking at our molecule, right, we had, just to sort of remind you, we had a central carbon. We had a central carbon that was then double bonded to an oxygen. That oxygen had 2 lone pairs on it. And then we had a single bond to one hydrogen and a single bond to another hydrogen. This is what we need to draw, okay? Well, in order to draw this, we need to turn what is currently just 2 circles bonded to each other into a single bond into this structure. So the first thing we're going to do is we're going to highlight that red circle, and we're going to change the number of things bonded to it to 3. We want 3 things bonded to that red circle. That red circle is going to represent our carbon. Now, we're going to go ahead and change the element of that red circle to be carbon. Bam. Now, carbon is in the center of that red circle. It's got 3 things bonded to it. Now, 2 of the things, which I'm going to select the first one down here, are hydrogen. So I go ahead and select that hydrogen, make it a hydrogen. Then I go ahead and I select the other black circle down the bottom and go ahead and make that a hydrogen. Okay. Now that circle that has not been defined yet up the top, I'm going to select that. I'm going to go ahead and make that my oxygen. Okay. Now I know that that oxygen, while I have it selected, it needs some lone electrons. It actually needs 4 lone electrons, 2 pairs of lone pairs, so 4 lone electrons. And then if I go ahead and select that bond, I need that bond type to be a double bond, not a bond, a double bond. So now, if I look at my drawing that I drew, I said I had a hydrogen. I had 2 hydrogens bonded to a central carbon, which was then double bonded to an oxygen with 2 lone pairs. That's exactly what I wanted to be. I'm going to click done. And it's going to tell me. So first it's going to load in the drawing that I did, and then I'm going to do show answer. And it's going to show me that I have drawn the correct Lewis structure. And I'm done.